tonight. So I think it's tonight. I just check on scale it. And yeah, so I think this maze problem is quite common. Like especially when I do my kids' homework. So it's usually something like this. I mean, it's nice that I mean the maze could be a bit larger than this one, but yeah, I mean, if humans could do it, then computers could do it too, right? I mean, the that's the optimism with respect to AI. And yeah, in fact, yes, computers could solve this kind of maze problems. So uh, I think you have found like even more complicated map and something like that, and you could do it, right? But in this case, it is like just 5 times 5, so not as big. But the main point is to get it right, to get the idea of BFS, breadth first search, and depth first search. Okay, and this might seem a little different to to this problem of map, right? I mean, when you do path finding on map, so I think this is kind of clear. Like this is like the node arad, and the link would be the connection, the road between arad and CDU. But here on this maze, so the idea is that I think you could see each cell, yeah, each style, y, x, y as a node, and then the link would be, I mean, like the adjacent nodes, right? And that's the idea, okay? From y to x and so on and so forth, okay? And you just have to be careful with the data structure underlying your approach, whether it's BFS or TFS. And, and of course, you could look at the slides again to be sure, and this book chapter. I think it could help you a lot. So just take your time and then like get some pieces of paper and pen. I think perhaps like do it in at most an hour. I think you'd be good to go. So yeah, that's it. But yeah, nowadays it's like uh, it's really tricky to have like an hour without any distraction, right? Disruption. I mean, social media stuff and Twitter like that. But that's why it's 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 tough, but I think you can do it. I think you can do it. Like to be focused, to be concentrated on on doing the weekly reflection, yeah? and finish it like well. That's the idea. I mean, you could like turn off like uh, your social media for an hour, and I think you'd you'd feel like how many things could be accomplished if you turn off your social media for an hour. Yeah. Okay. That's about the homework, right? The weekly reflection. Um, but the main goal is for you to to know AI, to understand AI, and to be able to use it uh, in your future career. That's the idea. Yeah. So don't think this like okay, yet another homework, yet another weekly reflection. No, no, no. That's like that's so yesterday. I think. I mean, uh, you should all be happy that you have your coding interview questions like beforehand, before you really have to do your real coding interview questions, because your coding interview question, I don't know, maybe at some later point in your life, it could be something related to BFS, BFS, A star, 3D search, and so on. And I'll just hope that the things you learn right now could be useful for your future self. So that's the idea. Okay. But this is like you couldn't ask questions uh, to me regarding answers to this, obviously, but you could ask questions regarding the course material. Okay, yeah. A state space. So you need to be able to represent. This would be a bit fast because you saw it last week. Right? How to formulate your problem, your goal, your problem, and searching and execution. So that's important. Um, so how does state space look like? That's also important. And yeah, the idea is how do you traverse over the state space? And this is again like how do you model like an AI problem using state space, right? And in this case, you have state, possible action, goal, task, path, cause, and transition model. So even for this vacuum cleaning world, I mean, if you get the idea of this vacuum cleaning world, so I believe that we could also do it for a more complex problem with some thoughts. Okay. And yeah, if you have a state space, so you would like to search, um, I don't know, like a solution hmm, from your initial state, starting point to the end point or the goal state. Um, Yeah, and there are two different approaches, like research where you don't care if you have visited like node previously, but for research you do care, right? So the difference is on the that you don't have an expert set here, the set for expert nodes, but while for the graph source algorithm you do have this expert set. So and there are several search strategies, two different streams, uninformed without heuristics and informed with heuristics. Yeah? So BFS, UCS, DFS, depth limited search, and iterative deepening search. Uh, at least you should be able to explain and to get the concepts for BFS, UCS, and DFS. And you should be good to go for the exam. Okay, so we did it already. BFS, it's Q, based on Q, and and UCS, it's based on priority queue. Um, and DFS is based on what? I'd like to ask questions. So to Abdi, hi Abdi, hello, hello.
Sir.
Okay, so well, breadth first search we use this queue, and UCS we use this priority queue, and then for depth versus we use what kind of data structure?
Breadth first search uses a queue data structure, I think.
Queue is usually for BFS, right?
Oh,
DFS,
just first. Oh, stack.
yeah,
Sorry.
DFS depth versus. So it should be something not queue, right? I mean,
Yeah, it's
because
a stack. Sorry, sorry.
yeah, that's correct. Okay, nice, thank you. Okay, so you get the idea. So that's nice. You, you should like review some I mean the difference between what is stack, what is a priority queue, what is a queue, and you should be able to do the exams here. Um, and also be careful with the tie. If there's a tie, yeah, if there's like a tie of something like, okay, there's like B and C from the root, which should which should I visit first? Which should I remove first from the frontier? Which should I put in first to the frontier if there's a tie? There's usually like some rules that I'll usually make it explicit so that you won't get confused. Just be sure that you read the instruction, of course, right? I mean, otherwise, then it could be like mixed up between B or C, and which should be taken out first from the frontier. So yeah, just be like uh, be a bit more detail on this matter because it's important because it could be P first, it could be C first, but you don't know. Right? It depends on the instructions. But if the instructions are unclear, so you could write down your own assumption. Yeah, but I usually try to make uh, these assumptions clear. Okay. Um, I think that's about it for the review of last week's material. Okay. And now, okay, this one, informed search. So now we are here in this informed search topic, but if there is still like some question on the uninformed search, please feel free. Otherwise, I'll just move on to informed search. Okay, yeah, let me just move on here. This should be full screen right now. Okay, so uh, obviously, if there's the term uninformed search, so when you get rid of the un to be informed, then you have this informed search. So, but what what is what would be the information here? Right? I mean, informed means that you get some information beforehand. So the information is kind of heuristic, so that your search could be a bit more guided instead of like blind search something. Yeah. Okay, so let's have a look. So just two outlines. Okay. Yeah. So when we do search, we tend to kind of best first search, right? In a sense that especially if we want to get like shortest path for the solution, yeah, and we don't have we don't really have something like this for BFS or DFS, assuming that the step codes could be different. Yeah, I mean, if the step codes are the same, then okay, DFS and DFS still matter. But if the step codes would be different, yeah, I mean, you know the Humania problem. So we have this kind of different step codes, right? From one city to other cities. Different. It's just like you have different word length, and that's why this kind of this thing would matter. You like to at the end you like to have like a solution with the minimum fn. Yeah. So and here, what is actually fn in this case? So we actually, when we do something with UCS, let me just briefly look at what UCS is. Okay, this one. So UCS is cool because it works even when the step codes are different. In the sense that it works in the sense that you get the shortest path. It's optimal. I think it's written here. Yeah. So second, uniform constraint. Yeah. Yeah. So here you are using priority queue in the sense that it depends on uh, the path cost so far to get to the node. Yeah. It's basically accumulating the step cost from the root to some node to other node and at the end to that node. So if you just sum up all the step costs, then it would become the path cost. Okay, and of course, you don't want to to prioritize the node where the path cost would be like very high. You would like to prioritize the nodes with the I don't know lowest path cost, right? And that's the idea of this uniform cost search. However, here we only we only care because now we are talking about informed search. But this uniform cost search is actually still uninformed. Even though you'd be able already to get to this sort of space solution, which is nice, but you have no, you have really no clue, right? Whether that CBU is actually closer to Bucharest than Zeri. I mean, of course, if you look at the map, then it's clear, but for the computers, it's unclear, yeah? Because the computer would start from Arad, and it only knows like the adjacent cities, Zarin, CPU, and Timisoara. I mean, if you look at this, Zarin is actually closer to Arad, yeah? But Zarin is actually like quite far from Bucharest. The CPU is close, and that thing that if you look at it, like I mean, it's really clear that CPU is closer. Why? I mean, if you take like direct line, like straight line, without really, I mean, it's like when you do kind of cheating. So you could just go like through a helicopter or something, right? From CPU to Bucharest, from Zen to Bucharest, and then the path would be just like direct and straight line, from CPU to Bucharest and from Zen to Bucharest. Yeah, which I think we humans actually do. So if you are here in Earth, I mean, the way I do it, I mean, this search, like even if I don't know any, I mean, any algorithm formally, I would just go to CPU. I mean, why should I go to Steamisora? Why should I go to why should I go to Aradia? It's even further. Yeah, I mean, it's less promising. When you go to CPU, it's like more promising. It's closer, and then it could, and the solution. We humans tend to have like really good solution, really cute, really quick. However, it could be not optimal, right? Like, and then as humans, I think, which would we choose next from CPU? Maybe I would like to ask one human. Okay, perhaps Frozen, Tito. Hey, are you well?
Well, yes, I'm here. I'm apologies for the late mic because I have too many tabs to open.
Ah, I see. No problem. Okay. So you
Okay.
mean you're online, but you are already here. I don't know what it's mean.
Well, there is some multitasking in my field, so yeah, kind of like that.
Okay, there's another. Okay. Um, but it's just very quick question. So, if you would like to go to Bucharest from CPU, which city would you want
Okay.
to go? Yeah. Mhm. So from CPU to Bucharest, would you like to go to Fagaras or Rimini?
I think I will go to. Let me calculate it a bit.
No, no, no. You
I
don't have
think.
to focus anything. It's just like
Oh,
very quick solution. Like it doesn't have to be the best. I mean, as you just use intuition, something like
well, my intuition is basically involving calculating because I love calculating. So I think
that.
yes. Well, I think I'm going because from my calculation I will go to Rimnishu.
Okay. Yeah, okay. Then since you already use calculation, then I think that I mean that would be the shortest path actually. Uh
Yes.
is really sure. Anyway. Okay. I still look for another human. But anyway, I think since you already spoiled the the solution, but let me give you some perspective then. Okay. So yeah, that's interesting. But we might think of another like city to choose, for example, Fagaras instead of Vinicu, simply because okay, it's fewer cities. It's just like one city, and then Vola, I'll be there at Bucharest. But if you go to like Vinicu, yeah, there are two cities. Like I mean, as long as you just don't care, you don't really care on like these numbers 99, 211, and something like that. Then okay, Fagaras, I think Fagaras and Bucharest, that's like fewer city. But then after you evaluate the solution, you just realize that it's actually not the shortest one. Right? From Arad to CBU, I mean, CPU Fagaras Bucharest, that's not the shortest one. But since if you involve the computation calculation, then sure, it's actually CPU Rimnicu, Vitesti, and Bucharest. So that would be the shortest path. I mean, you could just sum up the step cost from 99 211. It's compared to 80, 97, and 101, and that's like um, going from CPU to Rimnicu and Vitesti would be like shorter than going from CPU to Bucharest to Fagaras. That's the idea. Yeah. But the idea is just that uh, we have like tendency to find like as fast solution as possible, even if it's not optimal. It works in most cases because like when you have to make like really quick solution for some problem, like maybe almost needs to reflect, right? Your reflex actions, something like that. So you'd want to use like some heuristics, some intuition. So and that's why we have these heuristics, and that's why it could be that using heuristics alone could give you already a solution for this map problem. And what would be a possible heuristics in this case? I said it already, but I'd like to just check again. Uh, okay. Maybe Faras, if you are around, right?
Yes, sir. Sorry.
Yeah. So for this kind of map, uh, I think we could have something like heuristics to guide our search. So from Iraq to Bucharest. So rather than just like because different cities would have different potential to go to Bucharest, right? I mean, you agree that Zerin would be less promising than CPU, right?
Right. Yes, sir.
Yeah, to get to Bucharest. So, but then you say that you agree because. So, could you explain to us?
Sorry.
Yeah.
What
So
kind of
you
what
just
kind
said
of
that
example?
you agree that Zerin would be less promising than CPU.
Uh,
Mm-hmm.
in distance from Bucharest, right?
Yeah, yeah, yeah.
So I think since CBU is closer to Bucharest in this map and take less road, so I think CBU is closer than Bucharest compared to Zerin.
Mm-hmm. And what did you use to understand that CPU is actually closer than Zerin? So did you use some kind of intuition or something like that?
So besides of intuition, yeah, I kind of traversing the path from Bucharest to both cities, to CBU and Zerin, and I think from my traversal, CBU is much closer than Zerin, so CBU is more promising.
Mm-hmm. But if you did already the traversal, then you already did the job, right? The thing is that
Yes.
you need not do the traversal, but you know that which
Oh,
is more promising. And the solution is use the straight line distance. That's the solution.
okay.
Yeah, so that's the idea. Yeah, I mean, it's just like I would like to make explicit step-by-step process, like why we need to use these heuristics and why it's like why it could be useful. And then the A star search is like the next step. Yeah, the A star is like when you combine the idea of UCS and the idea of using heuristics. Well, actually, using heuristics alone, that's already kind of good enough, but we would like to have like really the best solution, and the one with using only the heuristics would be not enough. We would like to get best solution, good enough but not the best, right? And that's called actually 3D search for the solution with using just the heuristics. So that's the idea, and let me now show you the slides. So okay, there it is. Okay, yeah. So that's why there are two approaches here: the 3D search and then the A-star search. So maybe we can start with the 3D search. But first, we actually still use priority queue here, and it is prioritized depending on the value of fn. Yeah, and it's actually the I think it's the lower the better in this case. So the lower fn the better. And just a second, I think that okay, that's it. Yeah, and then what is heuristics? So linguistically, heuristics like rule of thumb, tips for success, like some guidance. However, a heuristic is called heuristic because it couldn't really give you like 100% guarantee, yeah, because it's heuristics. So, but the idea is it could give an estimation like how good uh, a state is with respect to reaching the goal state. Yeah, and let's see what we could use as a heuristics. So for this map, this Romanian tourist agents. So we have this map of Romania, and now we have this new kind of information we didn't have before. It's called the straight line distance table. So from each city to Bucharest. And if you look at it, like Arad is very far. Yeah, it's like 266 probably kilometers. I'm not sure whether this reflects reality, but anyway, yeah. So the idea is Arad to Bucharest. If you take like straight line, yeah, from Arad to Bucharest, then it's 266 kilometers. And then from Bucharest to Bucharest, of course, it's 0 kilometer. And from Craiova, where is it? Craiova. Okay, it should be around here. This one, Craiova, it's like 160 from Craiova to Bucharest. I think it makes sense, eh? I think if you look at it, like Arad, it should be further than Craiova to get to Bucharest. Makes sense. And what about Sibiu? We look at Sibiu, it's 253. We are getting closer. But what about Zerin? So Arab is like 266 and Zerin is like 374. Even though you would see that Zerin is like closer to Arab than CBU to Arab. But then what's the point of like of it being closer, right? If you actually like uh, go to the opposite direction to get to Bucharest. So yeah, but here we have these heuristics that we could use to guide our search. Yeah, and in this case we use so-called straight line distance. So from each city to Bucharest. So it's called HSLDN. N would be the city, the node, and H is for heuristics, and SLD is for straight line distance. And what is exactly this greedy search? So the idea of this greedy search is is that it's greedy. In what sense? So it's just taking the heuristics value of each node. So and then it like to get the lowest one, the node with the lowest heuristics. And this actually sums up nicely what greedy search does. So it always selects for the next node. So the next nodes that seem, yeah, it's not like that are, it's like that seem to be closest to the goal, because that's what heuristics does. It's like estimation. That's why you still couldn't be sure, but at least it's like good approximation. So for this map, assuming that we have this kind of table, I think yeah, the table is here, but I think we could do this kind of uh, kind of intuitive reasoning, to see even without the table, yeah, to see that art is actually closer to Bucharest than CPU and so on and so forth, right? So from art, which city would like to go next? So the idea is then, okay, then as this says, So get the one, so do not expansion on the frontier with the smallest HN value. So in this case, you only have Arab. So the node in the frontier with the smallest HN value, only one node. So then you have no choice but to expand Arab, and you expand Arab, and you get three cities, yeah, and you get the cities, Sibiu, Timisoara, and Zerin. And now we have this interesting situation where where we could use this kind of heuristics, right? So what is this number here below the node, below the city node? We have like CPU 253, Timisoara 329, and Zerin 374. So the idea is that these are actually numbers representing the straight line distance from each city node to the goal node, Bucharest. CPU 253, let me just check. CPU 253, and maybe Zerin 374. Yeah, something like that. Yeah, and because of the 3D principle, so which city you like to choose next, and that would be the one in the frontier with the lowest HN, and that would be Sibiu because it has 253, the lowest among others. Okay, and you pick this Sibiu and you expand it. After the expansion, you have Arad again, and Fagaras and Rimichu and Oradia. Okay, and here you again use the greedy principle. So pick one city with the lowest heuristics among all, actually, right? Among all. So not just here, but among all. And then because your frontier follows the priority queue principle, so the lowest HN would get to the top, which you'd like expand next, you would pick next, and that would be Fagaras, right? Just 176 is like it's like even lower than Rimichu because Rimichu has like 193. Okay, and then you'll pick Fagaras and you'll expand it, and you have Bucharest. But actually, we check again, right? We check again in your frontiers. So which has the lowest heuristics? So Arad 266 CPU and Timisoara, but hey, we have Bucharest. Bucharest is 0. Then you pick it, and that's it. You're done, and you get a solution to this problem of getting from Arad to Bucharest using greedy search. And the solution is from Arad to Sibiu to Fagares and to Bucharest. But then there's actually an issue with this solution. And could you tell me what would be the issue? Perhaps Seto. So Seto, are you around? Hello. Yep. Yeah, but it's like a little bit like quite low. Volume. Okay, perhaps if you don't mind, you could like just type it in the chat box. So, is there a problem with the solution given by the security search? So, if you could like type it down. Mhm. So, there's an issue with this. So, can you tell me? what's the issue with the solution? This 3D vector search solution, even though it could give you it is a solution, right? You could really go from Arad to Bucharest, but there's like a problem here. So maybe you could write it down if the mic like has a problem.
Sorry, sir. I have a question.
Oh yeah, yeah. Go on. Yes.
Where does the numbers below the Arab the locations comes from? Is it comes from the SLD?
Yeah, exactly. So the idea is this one. So you have it is given. It's a straight line distance table, and that's actually the heuristics. And if we look at this one, this solution, you have the numbers below each node. Right?
Yes.
That number is for the heuristics, the straight line distance. Yeah, that's right. Okay.
Oh, okay, okay. Thank you, sir.
Yeah, welcome. So Seto, right? So Seto, could you help me out? There's still a problem with it, Seto? With the solution? Could you point out what is the problem? Mm-hmm. Or if you still have any question, feel free to ask me. It's all right. You could also ask me question, of course. So, or you need more time? Hi, Seto. Oh, you need more time? Goes to the edge with higher value. Ah, I see. Yeah, I mean, I think you're right. So it goes to the edges with not really an optimal solution. I think it's it's a way to put it, right? So because there's actually a better solution. So the solution is not the best one, not the optimal one. Yeah. I mean, if you calculate, so from Arad to CPU to Fagaras and to Bucharest, it's actually longer than if you go to from Arad, CPU, Rimnicu, and Vitesse and then Bucharest. Just try to do this the sum, and I think you notice that this actually is not the best solution. Okay, but I just want to make sure that at up to this point, hopefully you get the idea of this 2D search. So is that right, or do you still have any doubts, any confusion?
Sir,
Oh yes, Saddam.
may I ask a question? Like,
Mhm.
could you go back to like the two slides before? The one that shows the slide, no, the straight line numbers.
This one, yes.
Yes. I want to ask a question about
Sure.
for like the city like Glurgi. Did I pronounce that right?
Yeah,
Like
I don't know.
Glurgi to Bucharest has like 90 distance on the map, but on the straight line distance to Bucharest on the right side, Glurgi has 77. So I'm a bit
Okay.
because
Yeah, yeah,
Glurgi to Bucharest is straight line right on the map.
yeah, yeah. That's
It's
true.
19
So,
and 77.
so it has to do with the principle of this heuristics. So heuristics tend to underestimate the cost for whatever reason. For example, it could assume that the road from Gyuju to uh, I don't know if I think I pronounced it wrong, but anyway, there's no Romanian here, so no one would know. So from Gyuju to Bucharest, it could have the assumption, the straight line distance. It could have the assumption that the road is really like a really straight road, but the assumption might not be true. So I maybe there's like a highway, then that could be somewhat true. But suppose that there is no highway from Gyuju to Bucharest, so it's really unlikely that the road will be just like going straight forward from Jeju to Bucharest, right? And then you
Also,
could just
like the map implies like there's a curve or something like that.
yes, yeah.
Okay, I thought
And
it's
then
from the graph, like, yeah. Okay, I get
yeah, I mean
it.
that's the idea of these heuristics. Yeah, it assumes that it is like really the best in the best condition. Yeah, I mean you could have also like slippery road or something like that, and you could have like I don't know some other condition like you have like traffic light or something like that. Yeah, and yeah, I think the curves would really explain this stuff. Yeah, because like the straight line distance like this. But I know where the confusion came from because you see in this case it's really like simplification of the real condition. Yeah, but because here you only see the straight line really like from Jeju to Bucharest, but perhaps if we I mean just try Google Maps. I mean I don't think that from Jeju to Bucharest and it's like really just like straight line and where there is like a road really following that straight line and where the road is like really so smooth and then you could really do be there like really in the best possible way. But yeah, but thanks for raising this up. So I think this makes sense. So for these heuristics to be a bit overestimating, sorry, a bit underestimating. Yeah, because if it's overestimating, then I mean heuristics is overestimating, then you could get stuck to the place where it is like it gives like false idea of effectiveness. So, but we'll come to that later about it's called the admissibility of heuristics. So, a good heuristics must be admissible. For example, it never overestimates. That's the idea. Right? Because if it overestimates, then it could have this problem of not having the shortest path as the solution. It's if you could have like uh heuristics that is as close as possible to the real best shortest path solution, that's that's okay, that's really nice, that's best, but in general we couldn't have it, right? I mean if you really have like solution that like very close to the real path course shortest one, then I think you know that one, the heuristics, you know that the heuristics is close because you actually have computed it. You already have computed the shortest path. But the idea of the heuristics is that you you don't compute the shortest path. You just have like some kind of guidance. So from I mean, even if it seems it doesn't seem make sense at first, like how could you take like a helicopter to go from Sibiu to Bucharest? Like not everyone would have helicopter, but that's not the point. The point is that like this is like good estimation that doesn't overestimate the distance, and this is called straight line distance. Yeah, that's for greedy search. So thanks for the question. I think that's a nice one. So and yeah, we saw that this greedy research could have like problem on the optimality. Yeah, it's not optimal here. It's not optimal, no, but it could be, let's say, incomplete, right? So, for example, I'll just give you an example. I think let me just give you like this map. I think I'll like to have um some marker just to let you know. Okay, it usually takes time to okay to load this feature. I don't know if you could let me see what you could see. Okay, I think it's the same. Yeah, so I have this marker right now. Let's see. Suppose you have just a second. Okay. Suppose you like to go from this one. Yeah, see, yeah, to Fagaras, right? And you use this greedy search. And the greedy search is like you don't even have this kind of way to handle repeated states. I mean, in this version of greedy search, because you could have like another version of greedy search where you could handle the repeated states. Suppose that you don't handle repeated states. So in this case, let's say the distance from Iasi to Fagaras, I'll use like smaller number, perhaps 10. And the distance from Neam to Fagaras, let's say 7 or so. And the distance from Faslu to Fagaras, I think it's like 12 or something. So my question is that you start from Yasi and you like to get to Fagaras. And now you use the 3D search, right? So question time. So if I have questions, don't worry if you couldn't answer yet the questions, because this is more for just to hear your voice. You know, like I like to hear your voice. I like to be interactive. So maybe Yolanda. Hi Yolanda.
Yes, sir.
Yeah. So my question is, if you use the greedy search to to go from Yasi to Fagaras, so which is the next step? So is it like Neam or Faslu?
I would say first Louis.
Uh, okay. So greedy search would prioritize the one with the lowest heuristics, right?
Oh yeah. So okay. It's supposed to go to Nam.
Yeah, suppose you like to go from Yasit to Fagaras at the end, right?
Hmm.
And you use the heuristics like the heuristics that we just discussed, yeah.
Yeah.
And then for heuristics search, greedy search, you just would like to get the next as the next node, like the one with the lowest heuristic value, and that would be what? Neam or Faslu?
Nam.
Neam, exactly, because like the straight line distance is just 7. That's right. Okay, thank you. Okay, next then. And then I'd like to ask Abraham.
Yes,
Hi.
sir.
Okay.
Hello, sir.
Yeah, and what would be the next step? So from Neam, suppose we just do not record the visited states, so we could have repeated states. What would be the next step from Neam to get to Fagaras?
Mm, it will go directly to Fagaras.
No, no, there's no. This is like an imaginary line, so it's like
Oh,
straight lines.
oh
Yeah.
yeah. So it will go back to Yasi again.
Okay, thank you. And then let me ask Akbar. So Akbar, yeah, if you are already here at Yasi, yeah. So the so the path was like from Yasi to Neam, and then go back to Yasi, right, Akbar? And what would be the next step if we use the 3D search? Go back to Neam again. Perfect. And I think you already know the pattern, but just to be sure, so I'll touch. Hi.
Hello,
You,
sir.
yes. So Akbar said that we should go back to Niam again. But then, what's next?
Go back to ES again.
Yeah. And I think I shouldn't really call each one of you, because it's like just like going back and forth, and so on. Yeah, but at least now you get the idea, right? What could be a problem with this greedy search? Because it's greedy, so it could be fast. It could be super fast, but it could get stuck to this like uh, infinite loop, and it could get stuck to it could it could get trapped in some kind of solution that is actually not optimal. So that's the idea, and you saw it, right? We just demonstrated it, so it's really nice to have this kind of live demonstration. Okay, what could we do to improve it, right? So that's why we have this A star search. Hmm? But perhaps I think we deserve like 5 minute break for this. Okay. So let's take a break for 5 minutes.